Hello everyone. So today we are discussing about the Indian soil classification system. ISSCS, and here we will discuss about how the soil is classified into the 18 groups, and then about that plasticity chart, which divide the soils or fine grained soil into the different uh, categories or different types. So here the in the x-axis it is about related to the liquid limit, and in this y-axis there is a plasticity index IP. So basically we are going to discuss about these topics. So if you consider about the Indian standard soil classification system, this one is adopted by the Bureau of Indian Standard, and it is in many ways similar to that of Unified Soil Classification System. It is similar, and the main difference lies in the classification of the fine grained soil. Fine grained soil. So main difference lies in the fine grained soil, because Indian soil classification system classifies the fine grained soil as having low, medium, and high compressibility. It has low, medium, and high compressibility, whereas in the case of the for all three, low compressibility, medium compressibility, and high compressibility, whereas in the case of the um, unified soil classification system, it classifies soil into the low and high compressibility only. It low compressibility, either low compressibility and high compressibility. So first, we already know that soil is classified into the 18 groups. So now we learn about the symbols. So there are primary symbols and secondary symbols. So primary symbols we have as Z means gravel, gravel, and then S means sand, and M means silt, C means clay, and then O means organic soil, whereas PT means peat. And there are the secondary symbols as well. These are the primary symbols. So if we consider our secondary symbols, were these secondary symbols. secondary symbols, and here is the description. So first W means well graded, and this P means poorly graded. P means poorly graded, and then L means low plasticity. So L means low plasticity, and then H means high plasticity, and then I means intermediate plasticity. So these are the secondary symbols. So primary symbols we have to understand is gravel, sand, silt, clay, and organic soil and peat. Whereas the secondary symbols we have well graded gravel, poorly graded gravel, low plasticity, H for high plasticity, and I is interest. So we are going to use these symbols in order to um, classify the coarse and fine grained soil. So first the now we are going to write about the 18 groups. So following are the 18 groups of soil we going to write. So first is, you go here, see here it is G for gravel and W is well graded, so we write it GW. So first number GW we are going to write, it is known as well graded gravel. So first is well graded gravel, and now we going to write again related to gravel only now, but poorly graded gravel, so it goes serially. So it is GP, second one is GP. So this one is poorly graded gravel, this one is poorly graded gravel. In the case of the well graded gravel, we have coefficient of uniformity is greater than 4, whereas coefficient of the curvature lies between 1 to 3. In the case of the now we are going to write which one is gravel but of the silt. Now silty gravel and clay gravel, also we know that there is also relation between the silty gravel and clay gravel. So now let's write about silty gravel and clay gravel. So first it is related to well graded and poorly graded. So first gravel grows to well graded and poorly graded, and now it lies within the primary symbol. First between primary and secondary symbols, these two, well graded and poorly graded. Now we have to write within the primary symbols, that is silty gravel and clay gravel. So the symbol is as write it with other pen. So symbol is as GM. So GM means silty gravel. So silty gravel has the plasticity index less than 4, silty gravel, and the other is clay gravel. So the phone number we write clay gravel, and it has plasticity index greater than 7. So all these 1 2 3 and 4 we have It is called gravel if greater than. So in this, what happens is in the 1, 2, 3 and 4, that is GW, GP, GM and GC. So all these are known as gravels. When these has greater than 50% retained on, these are known as gravel when greater than 50% retained on 4.75 mm ISC. So in such case, these things are known as gravel when greater than 50% retained. So for these 1, 2, 3 and 4 to happen, it is should be that greater than 50% should be retained on the 4.75 mm ISC. So we completed the 4 groups out of the 18 groups. Now the next group from number 5 we will write about sand. Now we wrote about the gravels. Now similarly we are going to write about the sands too. So now the case of the sand, we have sand. So sand also we go here first, well graded sand and poorly graded sand, and then back to the table, that is silty sand and clay sand, similar to gravel. So first we write what it is: well graded sand, and then this this symbol is, we have to write the symbol first, sorry. What we write is SW, it is well graded sand. Well graded sand. So this has coefficient of uniformity is greater than 6. In the case of gravel, it was coefficient of uniformity greater than 4, and coefficient of curvature in this case is also between 1 to 3, same as that of gravel. And now we write poorly graded sand. And 7th number we have SM, that is silty sand, and it has plasticity index less than 4, and the other is SC, that is clay sand, and it has plasticity index greater than 7. And all these 5, 6, 7 and 8, that is 5, 6, 7, 8, that is SW, SP, SM and SC. So these have to be greater than 50%, should be passed through 4.75 mm sieve, IS sieve. So in this case, this is known as sand. In the above case, greater than 50% should have been retained. So here is the difference. Greater than 50% retained, it is in the 4.75 mm sieve, it is gravel. And when greater than 50% is passing through the 4.75 mm ISCB, it is a sand. And these both 1, 2, 3, 4, 5, 6, 7 and 8, so these are wholly classified as coarse grained soil. So both these 1, 2, 3, 4, 5, 6, 7, 8, so whatever we wrote 1, 2, 3, 4, 5, 6, 7 and 8, these in a whole are greater than 50 percentage. If here we wrote about 4.75 mm, so now this 1, 2, 3, 4, 5, 6, 7, 8, so this one well graded gravel, poorly graded gravel, silty gravel, clayey gravel, this is 1 2 3 4, and 5 6 7 8, that is well graded sand, poorly graded sand, silty sand, and clay sand. If all of these greater than 50% retained on 0.075 mm ISSCS, then these are known as the coarse grained soil. So greater than 50% written on the corner. So first, this 4.75 mmC is regarded as a criteria to classify between the gravel and sand, and if more than 50% is written, it is gravel. If less than 50% written, it is a sand. But this 0.075 mmC is used as a criteria to classify the coarse grained soil and fine grained soil. If more than 50% written, it is a coarse grained soil. So if greater than 50% passing, it is known as fine grained soil. So this is the case. So now we write our same thing in the case of the fine grained soil. So fine grained soil. Here we wrote about the first 18 groups finished, 8, and then from 9 we going to start. So 8 finished. Now this for the fine grained soil we start from 9. We start from number 9 because we have to complete the 18 columns. So above this were of the coarse grained soil first. This 1 to 8 were of coarse grained soil. Number 1 to 8, and from 9 to 18. So fine grained soil are going to be from group number 9 to 18. So we were going to write here about the 9 cases. So fine grained soil are also classified as, how you do is, fine grained soil is the upper. Now we have to classify the silt, and then clay, and then also the organic soil, that is called mixture of silt and clay. So here we go into the plasticities in the case of the silt and clay. So here we say that silt of the low, here first here is the silt. So here, so we go for silt and clay. So silt of the silt and low, medium, and low, high, and intermediate plasticity. Again clay also low, medium, low, high, and intermediate plasticity. And again of the organic soil also, that is mixture of silt and clay. This organic soil is, so organic soil also low, high, and intermediate plasticity, same thing. And then finally we are going to write about peat and highly organic soil, and which makes up the 18 groups. So starting from the number 9, we have silt of low plasticity, clay of low plasticity, and again organic soil, that is silt, clay of low plasticity. So see, this is the silt of low plasticity, and this is the clay of the low plasticity, same thing. And this is the organic soil, that is mixture of silt, clay. Organic soil, that is silt, clay of low plasticity. And all these have liquid limit, that's less than 35%, and this is the 9, 10, and 11 number. All these have liquid limit less than 35%. So this is 9, 10, and 11 number, and all these have liquid limit less than 35%. Then now we go into 12. Now we wrote about the low plasticity. Similarly we go for silt of intermediate plasticity, clay of intermediate plasticity, and organic soil of intermediate plasticity. So these have the liquid limit between 50 and 35. So 35% to 50 percentage. This has 50 percentage, and then finally we this 13, this is 12, 13, 14. So this is the silt of intermediate plasticity. This is silt of intermediate plasticity and clay of intermediate plasticity, and that is the organic soil, that is mixture of silt clay organic soil, that is silt and clay of intermediate plasticity. So it is still 14 now. 15, 16, 17. This is the silt of high plasticity, clay of high plasticity, and organic soil, that is silt clay of high plasticity. So this is the silt of high plasticity, this is the clay of high plasticity, and this is the organic soil, that is silt clay of high plasticity. And these 15, 16, 17, so these has the liquid limit that is greater than or equals to 50 percentage, and the all these 9 to 17, so 9, 10, 11, 12, 13, 14, 15, 16, and 17. So these have the particles which when shipped greater than 50 percentage passing through. So 9 to 17 means that uh, silt of low plasticity is 9, clay of low plasticity 10, so organic soil is 11, and the silt of intermediate plasticity 12, clay of intermediate plasticity is 13, and organic soil of intermediate plasticity is 14. And then 15, 16, 17 will have silt of high plasticity, clay of high plasticity, organic soil of high plasticity. So all these 9, 10, 11, 12, 13, 14, 15, 16, 17 we written, these have to pass through the 50 percentage, greater than 50 percentage, passing through 0 0.0 075 mm, passing through this. So from 0 0.075 mm ISC, that is. So if this happens, then it is the fine grain soil. So if greater than 50 percentage pass through the 0.075 ISC, it turns out to be fine grain soil. So all these from 9 to 17 are fine grain soil. Now we have a plasticity chart. So we have a plasticity chart. Whatever we did these from 9 to 17, that is classification of fine grain soil, this can be shown from the plasticity chart. So we should understand this as well, plasticity chart. So how these 9 to 17 whatever we classified came from the plasticity chart. So here above we wrote about the 17 groups, and the last 18 group is 18th group number is related to the peat, that is here in the primary symbol we had written organic soil and there was peat remaining. So peat means nothing but it is written as peat and highly organic soil. So let's complete this and we draw plasticity chart. So this is peat and highly organic soil, organic soil. So this is the 18th group. So we completed 18th group. Now plasticity chart. So for the plasticity chart, what we do is here we draw chart. So it is in the Indian standard soil classification here. It is drawn from 0 to 100 on the x-axis, where it is the liquid limit. So let's divide it into the 10 parts. So 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, and then 100. So this one is the liquid limit, x-axis, and so this is the liquid limit, and in this side we draw plasticity index IP. Plasticity index IP, and this also goes from 0 to 60. So 10, 20, 30, 40, 50, and 60. So now let's draw lines so that it is going to be easier. So these vertical lines. So these vertical lines are drawn. ED, 90, and then hundreds, and then we draw this horizontal lines as well. 60. So this happens. Now we have to draw further lines too. So there is a line which has a formula of the plasticity line, that is called A line. So in order to get that A line we have a formula 0.73 into liquid limit minus 20. So this IP equation gives a line, and this A line divides the chart into two parts, that is above part. So how the line gets is, it starts from 20, because for WL is equals to 20, we get IP equal to 0 from this equation. So from this equation, if you put WL is equals to 20, you get IP equal to 0. So WL equal to 20, you get IP equal to 0. So it must start, when IP equal to 0, it must start from 20. And if you keep putting IP equal to 100, when you put IP equal to 100, then you get when you put WL equals 100, so when you put WL equals 100, you get IP equals 60. So you get IP equals around 60. So you put first point as 20, first point at 20 here, and then this point at 60. If you put this point at 60, so you join these two lines. So if you join these two lines, you going to get here, and after this there is a certain mark, that is from 4 to 7 here, from 4 to 7, and starting from here from the 10, there is a mixture of the swell you have to represent here. So if the swell data plot falls in this zone, you have to write this as clay of low plasticity and silt of low plasticity. So it is the clay silt of low plasticity kind of mixture. So if the while plotting, if your data falls in this region, then you have to write the soil classified as CL-ML in that way. So here this line is drawn, so this line is called A line, and its equation is IP equal to 0.73 into WL minus 20. So this line is drawn. So above this A line, whatever is plotted, it is classified as clay, and below this A line, whatever is plotted, it is classified as silt or organic soil. So silt or organic soil, not M, but let's write it silt or organic soil. It is written as, so whatever is plotted down, it is written as silt or organic soil. So let's remove this, and after this, the further this clay and silt are also classified into the three types. So if the liquid limit is starting from this, let's draw a line, which line, better we draw a blue line. So here if the liquid limit is less than 35, so in the Indian plasticity and ISSCS, in the ISSCS you have a line going from 50% directly like this, and this side is low plasticity and this side high plasticity. But in the case of Indian soil classification system, what they do is they have divided this plasticity into also three types. So here from 35, from 35, one goes line from the 35, one line goes from 35, so this line goes from 35, other line goes from 50. This is the liquid limit, so you classify soil, and above this liquid limit 50 you have other soil. So the above this line everything is clay, but what type of clay? So if it is this side, then you write clay of low plasticity, and in this clay of intermediate plasticity, because it lies, liquid limit is above 35 and below 50, above 35 and below 50, so we rate it clay as clay of intermediate plasticity. And here we write clay of high plasticity. So all this part is the clay of high plasticity, this much, and not this much is clay, and this is the, wait, this is the clay of high plasticity. So this much is the clay of high plasticity zone. And similarly, the clay is written now in the below portion we write silt of low plasticity or organic soil of low plasticity. Similarly here also silt of intermediate plasticity or organic soil of intermediate plasticity, and then silt of high plasticity or organic soil of high plasticity. So above this 50% liquid limit, it is high plasticity silt, and between this 35 and 50 it is intermediate plasticity, and bit above and below this 35 it is low plasticity silt or organic soil. So in this way we have completed our plasticity chart as well, and it's really important to understand this and asked in many examinations. So hope you guys enjoyed this information. Thank you so much. If you like this video, please like, share and subscribe the channel.